In this lesson, we're going to do some more practice problems for med math calculations for injectable medications. Let's just look at a few key points. So one thing you want to always look at with these is the units. What is the problem actually asking for? Are we looking for milliliters? Are we looking for the actual dose, like micrograms? Make sure you know what you're looking for. Some medications that might be used for injectables would be like IMs, sub-Q injections, intradermals, IV pushes, etc. So these are things that have a volume but may not have a time or a rate. As with any other problem, you always want to look at appropriateness. For example, did you get a result of giving 10 milliliters in an IM injection? That is not appropriate. We're talking about typically 2 or less, maybe 3 or less, but 10, definitely not appropriate. You should reevaluate, see if you missed anything. And then again, same with orals. You're typically looking at a per dose type of formula because you're not looking at a rate or a time. Okay, so let's work some of these out. First one, the order is 7,000 units of heparin sub-Q every 8 hours, and heparin available is 5,000 units per milliliter. How many milliliters should you administer? Now in these, I'm going to strictly use dimensional analysis because it's my preferred method. If you want more on how to use the formula method, check out the oral medications lesson or the basics of med calculations lesson. So the first question is, what are we looking for? How many milliliters? So I'm looking for the number of milliliters per dose. So always start with what you're looking for. Transfer your top units over milliliters. Insert what you know. Do I know anything? Am I given anything about milliliters? Yes, I am. I know that 1 milliliter is 5,000 units. Okay, transfer my units up. What else do I know about units? Well, I know that I want 7,000 units in 1 dose. Okay, cancel units. And am I left with what I want? Mils per dose? Yes, I am. Multiply across the top, divide across the bottom. You end up with 7,000 divided by 5,000, which gets us 1.4 milliliters per dose. The last step is always to verify. Does it make sense to give about 1.4 milliliters or to give 1.4 milliliters specifically in a sub-Q injection? Well, it's a little bit high, but it's not too high. It's appropriate. Let's look at the next one. Haloperidol, 2 milligrams intramuscularly 1 time. Available haloperidol 5 milligrams per milliliter. How many milliliters should you administer? Again, start with what you're looking for. Milliliters per dose. Transfer your top units across. Milliliters. What do I know about milliliters? I know that 1 milliliter is 5 milligrams. Okay, transfer units again. What do I know? Well, I already used this one. So the other thing I know about milliliters is that I want 2 milligrams per 1 dose. Cancel milligrams. I'm left with milliliters per dose, which is exactly what I want. Multiply across the top, divide across the bottom. 1 times 2 divided by 5 divided by 1 is going to give you 0.4 milliliters per dose. Does 0.4 milliliters make sense for an IM injection? Does it make sense for this calculation? Yes, it does. We have verified. All right, let's look at the next one. A nurse has drawn up 4 milliliters of furosemide to administer IV push to a patient. The vial contains 10 milligrams in 1 ml. How many milligrams is the nurse about to administer to the patient? Okay, start with what you're looking for. Milligrams per dose. Okay, what do I know? What am I given about milligrams? Right here, I've got 10 milligrams is in 1 milliliter. So 10 milligrams, again, because we transferred this unit across, 1 milliliter. Now, transfer the units up, milliliters. What else do I know about milliliters? Well, right here, I know that she's giving 4 milliliters in this dose that she's about to give, or he. Let's cancel milliliters. And are we left with what we want? Milligrams per dose? Yes, we are. Multiply across the top, divide across the bottom. 10 times 4 divided by 1, 40 milligrams in this dose. Is this an appropriate dose? Does this make sense? 10 per mil times 4, 40. this makes sense. 40 milligrams IV push of furosemide is perfectly acceptable. All right, let's look at one more. For an initial bolus dose before an IV infusion of regular insulin, the provider has ordered 0.1 units per kilo of regular insulin IV push. First of all, we know regular insulin is the only one that can be given IV, so we know that that part is appropriate. The patient weighs 132 pounds. How many units should be administered? So start with what we're looking for. Number of units per dose. Okay, transfer your units across. What do we know about units? Well, we know that we want 0.1 units per kg. So 0.1 units in 1 kg. Transfer units up. Do we know anything else about kg? Actually, we don't. So when you don't know, you convert. 1 kg equals 2.2 pounds. Transfer our units up. What do we know about pounds? 132 pounds. Okay, cancel kgs, cancel pounds, and we've got what we need. Units, and this is going to be 0.1 units per kilo per dose. Okay, multiply across the top. 0.1 times 132 divided by 2.2 is going to give you 6 units of regular insulin IV. So then ask yourself, does this make sense? Well, if we're starting an insulin infusion, we may have somebody in DKA or HHNS. 6 units of an initial bolus dose is actually appropriate. So that is going to be good to go. If you had come up with 60 or 600, that may have been inappropriate, but 6, that's good to go. Last one, protamine sulfate, 25 milligrams IV push 1 time, available protamine sulfate, 5 milligrams in 2 milliliters. How much are we going to give? Well, in this case, by how much, it wants to know volume. So we're going to be looking for milliliters per dose. Okay, transfer units across. What do we know about milliliters? We know that 2 milliliters is 5 milligrams. Okay, transfer our units up. What else do we know about milligrams? Well, in this case, we know that we want to give 25 milligrams in 1 dose. Cancel milligrams. Are we left with what we want? Yes, we are. So multiply across the top, divide across the bottom. 2 times 25 divided by 5 divided by 1 is going to get you 10 milliliters per dose. Is 10 milliliters appropriate for an IV push? Sure it is, especially if this is the right calculation. Makes sense. This is about 5 times here. 5 times 2 is 10. It's about right. So we verified and we're good to go. All right, guys, that's it for some injectable medications. Please make sure that you also check out the IV medication, IV infusions, the complex calculations, oral meds, the basics, and the dimensional analysis lessons so that you have a really great foundation for med math. We love you guys. Go out and be your best selves today. And as always, happy nursing.